So here are 4 different equations, okay? And each one has a different thing, a different operation that is kind of in the way of having the variable all by itself. Your goal in solving equations is to get the variable all by itself on one side of the equal sign, and then on the other side of the equal sign should just be a number that tells you what the answer is, then what that variable must be equal to. Okay, so in these equations, there's only one thing to get rid of, one thing to undo to get the variable by itself. And so that's what we're going to do. So and you do this by using what's called the inverse operation, okay? So if there's a number being subtracted, are people talking? What's going on? I'm trying to teach here. What's happening? Why are people raising their hands? Knock it off.
You can guess who it is.
I'm recording also. Okay, so let me get back to teaching. You need to do the inverse of the operation to undo it, okay? So in the first one here, there's a 6 being subtracted from x. Let me point out also, all of these problems, most of them anyway, you can do in your head, especially these one-step equations. I really don't care that you get the answer right. More important in these problems is that you do the correct step and you show it correctly, the correct algebra step for solving the equation, okay? And in this first case, the correct algebra step is to add 6 to undo this minus 6. If I add 6 to both sides here, then this side will go away and it will leave me with just x. If I do anything to one side of the equation, I have to do it to the other side of the equation. Okay? And then when I do this to both sides, I'm going to get a new equation that's going to be equivalent because I did the same thing to both sides. This minus 6 and plus 6 cancels out, and I'm left with x equals 16. 10 plus 6 is 16. And that's my solution. You probably get, if you put 16 in for x, then this comes out to be true. Okay, problem number 2. This is an addition equation. There's a number being added on to the variable, and it doesn't matter which side of the equation the variable is on. You can switch the sides whenever you want. Okay, so in this problem, I need to subtract 7 from this side to get the a by itself. But if I do it to one side, I have to do it to both sides to maintain the balance. Okay, so now when I do this to both sides, this 7 minus 7 goes to 0, and I'm left with negative 2 equals a. This one you might not have been able to do in your head so easily because it has a negative number in there. What number plus 7 equals 5? Negative 2 plus 7 equals 5. All right, next one is a multiplication. Okay, 5 times h, this means, right? So to undo multiplication, we do the inverse operation, which is division. We show division with a fraction bar. If I do it to one side, I have to do it to the other side. So this side I divide by 5, and this side I divide by 5. 5 divided by 5 over here equals 1. So this side is 1h, but I don't have to write the 1 because it's an invisible 1. So this is h on this side equals negative 30 divided by 5 is negative 6. Okay, so that means that my 5 times negative 6, does that equal negative 30? Yes. So that's the solution, the value of h that makes the equation true. And the last one is a division problem. D divided by 3 equals 9. Some people will say the answer is 3. It just kind of looks like it should be. But if you put 3 in for D, 3 divided by 3 is not 9. 3 divided by 3 is 1. The way to solve this equation is to undo division. The way you undo division is by multiplying. So we'll multiply this side by 3. And we'll multiply this side by 3. Same thing to both sides. 3 divided by 3 over here equals 1 again, leaving me with just D. And on this side, 9 times 3 is 27. So 27 divided by 3 equals 9. That's the right answer. That's the value of D that makes this equation true. Okay, so this is solving one-step equations. And the reason they're called one-step equations is because there's only one thing you have to do to get the variable all by itself, or isolate the variable. All right, so this is what your homework is for Tuesday, is to complete all of these equations. There's 10 on each side, I think, because the first 2 are done for you. And you must show that you are doing the same thing to both sides. All right, that's my lesson for today.